Hello guys, welcome in today's session. I am Professor Fayaz Karadi from Department of Mechanical Engineering. In today's session, we are going to learn on which concept the gyroscope is working and the terminology which is used in gyroscope from unit number 6, gyroscope from theory of machine subject. Before starting the actual session, in brief, I explain what is a gyroscope. So, gyroscope is a mechanical device which contains a heavy metal rotor, has 3 degrees of freedom. As you can see in this image, the heavy rotor is rotating above the axis XX. This XX axis is called as a spinning axis or spinning freedom. Along with this axis, this complete rotor is tilting about ZZ axis, that is called as a tilting freedom, and the complete rotor X and tilting axis is rotated about the outer gimbal, and this is rotating about YY axis. This is called as a weaving freedom. So any rotating metal, any rotating mass having 3 degrees of freedom is called as gyroscope. Now the gyroscope is working on the conservation of angular momentum concept. Now what is that conservation of angular momentum? The principle of conservation of angular momentum states that the angular momentum of a body about a given point remains constant unless some external force is applied to change it. That means that thing, that concept we can understand by the example of a rotating top or this rotating disc. This rotating disc is continuously rotating until some external force will apply on it. That means the angular momentum will break when you apply the external force to change that angular momentum or to break the angular momentum. You are playing the top, that top is rotating continuously, and if you apply the force with help of your finger, the angular momentum will break. So that is nothing but the principle of conservation of angular momentum. That means unless until you apply the external force, it will continuously rotate and the angular momentum of body will not change unless otherwise you apply the external force to change or to break this angular momentum. This is principle of angular momentum, conservation of angular momentum. And angular momentum is the product of mass moment of inertia, and that is denoted by I. And in general, you tell about the moment of inertia. And second thing is angular velocity omega. So angular momentum is the product of omega into I, or I into omega. I is moment of inertia or mass moment of inertia, and omega is angular velocity. If the rotor is made to rotate at high speed, if the rotor is made to rotate at high speed, then the device becomes the tool gyroscope, which includes two important basic properties. That means if you rotate any mass at high speed, that device becomes the true gyroscope, which includes two important basic properties. First is a rigidity and second one is a precision. Now one by one, see what is rigidity and what is precision. If the weight is mounted on the inner gimbal, when the rotor is spinning, it will be observed that the rotor will support the load instead of falling down. This indicates the property of rigidity. That means if the rotor is rotating about the x-axis, and at the same time, that means during the rotation, you apply the weight on the inner gimbal. That weight won't be fall down due to the spinning of a rotor. That property is called as a rigidity. That mass won't fall down due to the spinning of a rotor. And if that rotor is not rotating or spinning about axis y, at that time this complete assembly, a rotor and this mass due to the gravitational force will fall down. But due to the at the same time the rotor is rotating with high speed and you apply the load on the inner gimbal, that load won't fall down due to that rotation or spinning of a rotor about the axis xx that holds that load. That property is called as rigidity. At the same time, you can observe that condition, the complete gimbal system will start rotating about axis yy. This rotation indicates the second property, that is precision. That second property is called as precision. That means you can see in this image the rotor is spinning about the axis. This is the horizontal axis, and on that horizontal axis the rotor is spinning. Okay, and due to that spinning, if you put that horizontal axis xx and give the support or the load applied on that, it will directly start rotating about the vertical axis yy. This is the vertical axis yy. This is the vertical axis yy. That means there are two motion of the rotor, two rotation of the motion of the rotor is, one is a rotating or spinning about xx axis, and this another load is applied on this, or this is the support. Due to that support and due to the spinning of the rotor, it will start rotating about vertical axis yy. This rotation of the complete gyroscope about axis yy is called as precision. So in this image you can see there are two rotations of the rotor. One is a spinning on the horizontal axis and the complete gyroscope is rotating about the vertical axis yy. So there is a second rotation of this complete gyroscope, and this rotation about the yy axis is called as a precision. So spin you can see in different plane and precision you can see in different plane, which is perpendicular to each other. Spinning, we can say it is a front view or front plane, and the precision you can see from top, which is another plane which is perpendicular to previous one. Now see the terminology which is used in gyroscope. Before starting the terminology and the terminology which is used in the gyroscope. First of all, we have to understand which are the three different planes. These are three different planes: spin plane, precision plane, and gyroscopic plane. There are three different planes which are perpendicular, mutually perpendicular to each other. These three planes are mutually perpendicular to each other. Now see, what is spin axis? Spin axis, the axis about which the rotor or body spin is called as a spin axis. This is the rotor, and this rotor is rotating about the axis OX. So OX is called as a spin axis. OX is called as a spin axis. Spin plane. Second one, spin plane. The plane which shows the direction of spinning is known as spin plane. The plane in which you can see the actual rotation of the rotor or rotating mass, whether that rotor is rotating in anti-clockwise direction or it is rotating in clockwise direction. That rotation you can see in which plane, that plane is called as a spin plane. So this is the direction of observer. Observer is looking the rotor from left side, as here is shown by the arrow. Okay, this is the position in which you can see the actual rotation of the rotor, whether it is rotating in clockwise direction or anti-clockwise direction. So this will become the position of observer. From this direction you can see the actual rotation of the rotor. So in which plane you can see the rotation of the rotor, that plane is called as a spin plane. Spin plane. From top view you can't see the rotation of the rotor. From front view, from this direction, arrow direction, I'm showing with help of cursor. You can't see the rotation of the rotor from front view or top view, but you can see the rotation of the rotor from the arrow direction. So that shadow you can see on that plane. So that plane is called as a spin plane. Okay, YOZ. This plane you can see the actual rotation of the rotor. So that plane is called as a spin plane, and in spin plane you can see the spin axis as a point, not as a line. This OX, this axis from this direction you can see as a point on the spin plane. Second one is a precision axis. Second axis, first axis is a spin axis. Second axis is a precision axis. The axis about which the spin axis turns is called precision axis. The axis about which the spin axis turn. So this is the spin axis. This is the spin axis. So spin axis is turning through angle delta theta. So that turning you can see from top view, that top view. Okay, and this is turning about the axis OY, so that you can see from top view, that precision you can see from top view, and that precision, that turning of spin axis about OY axis, so that OY axis is called as a precision axis. Precision axis. Now, precision plane. The plane which shows the precision motion is called as precision plane. From top view, you can see the turning of this rotor. See, there are two motion. One is a spinning motion, spinning rotation, and second rotation you can see from top view, from OY axis. Okay. This is rotating around OY axis. So from top view, you can see the actual rotation of complete gimbal system or gyroscope, or this plane is called as a precision plane. The plane in which you can see the rotation of spin axis, that plane is called as a precision plane. And again, in precision plane, you can see the precision axis as a point only. In precision plane, if you observe from top view, that OY axis you can see as a point only. Okay. That means that complete rotor is rotating about OY axis, and from top view you can see that OY axis as point only. So precision axis you can see as a point in precision plane. Spin axis you can see as a point in spin plane. These two planes are perpendicular to each other. Now third plane is a gyroscopic plane. Gyroscope plane. This plane is mutually perpendicular to spin plane and precision plane. The gyroscope action or gyroscope couple you can observe in this plane. So the third plane, which is mutually perpendicular to precision plane and spin plane, is called as a gyroscopic plane. You have to clearly understand these three planes. The plane in which you can see the actual rotation of the rotor, that plane is called as a spin plane. That spin axis turn around the vertical axis OY. That rotation you can see from top view, and that plane in which you can see the actual turning of that rotor is called as a precision plane, which is perpendicular to the spin plane. And the third plane, which is mutually perpendicular to spin plane and precision plane, in that plane is called as a gyroscopic plane. And in that plane you can see the active and reactive gyroscopic couple. Now the next thing is the angular momentum vector. The angular momentum is a vector quantity, so it has magnitude also as well as direction also. Magnitude as well as direction. So the angular momentum is the product of mass moment of inertia into angular velocity, that is I into omega. So angular momentum is a I omega, is a vector quantity, so it have magnitude as well as direction. So what is the method to find out the direction of angular momentum? For that purpose, the right hand thumb rule is used. This rule states that the finger of a right hand should be curled in such a way that the fingertips indicates the direction of rotation of the rotor, and the thumb indicates the direction of angular momentum. This rule is used to give the direction of angular momentum vector of a spinning body. In this image, if you observe that body, a rotor from a right side, so this curling finger, indicates the rotation of the rotor. If you observe the rotation of the rotor from side, right hand side, you can see that a rotor is rotating by anti-clockwise direction. Anti-clockwise direction. So the curling finger, you have to curve your finger in such a way that your curling finger will indicates the anti-clockwise direction of rotor. At the same time, the thumb will indicate the direction of angular momentum vector. Here, this second figure, if the direction of, if you observe from left hand side, you can see the direction of rotation of the rotor is in clockwise direction or anti-clockwise direction. Okay, so your curling finger will indicates the direction of a rotation of the rotor. You have to fold the all fingers in such a way that the curling finger will states the direction of a rotation of a rotor. At that time, the thumb will indicate the direction of angular momentum. This is towards left. So this rule, a right hand thumb rule, is used while solving the numerical to find out the angular direction of angular momentum vector. So at the end of this session, the student can understood the concept of gyroscope and the terminology which is used in gyroscope. Thank you for observing, for watching this video.